Hi guys, welcome back to my mathematics tutorial. Again, my name is Peter C. Dogwa Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we are continuing with finding derivatives of trigonometric inverse functions. So in previous lesson, we solved the first four problems on finding derivatives of trigonometric inverse functions. So you can just review those problems, but better still, you can see how we find the derivatives of these functions now. So we have question 5 to 7. So question 5 says y equals to cot inverse of the square root of, so I'm just going to rewrite it as an exponent form. So x squared minus 1 raised to the power 1 over 2. So to find the derivative of cot, the derivative of cot is just negative 1 divided by 1 plus x squared times the derivative of x. That is 1 over 1 plus the angle or square times the derivative of the angle. So this is exactly what we're going to do. So y prime now becomes minus 1 all over 1 plus the angle. What is the angle? This is the angle. So it's x squared minus 1 raised to the power 1 over 2 all square times the derivative of the angle. So we use the extended power rule. We bring this power down, rewrite the expression, subtract 1 from the power. So if we subtract 1 from half, we're going to lead to negative half. Then we differentiate within. X squared is just 2x, and the derivative of 1 is just 0. So this x can cancel, this 2 can cancel this 2. So y prime now becomes minus. Now there is an x right here. So we have x all over. Now, because this power is negative, we can send it within the denominator. So remember here we have 1 plus. Now this cancel. So it's just x squared minus 1 times the root of x squared minus 1. So this cancel this one. You just left with x squared. So this x can cancel 1 from here. It's x. So y prime now becomes negative 1 all over x, the square root of x squared minus 1. So this is the derivative of cot inverse of x squared minus 1, the square root of x squared minus 1. So let's look at the next problem. These are just easy problems, very easy problems. So question number 6, y equals to sine inverse of 4x cubed minus 1. So again, the derivative of sine inverse of an angle is just 1 over the square root of 1 minus that angle or square times the derivative of the angle. So we're going to apply the rule here. So y prime now becomes 1 all over the square root of 1 minus the angle. This is the angle, 4x cubed minus 1 raised to the power 2 times the derivative of the angle. So this angle now is just 3 times 4 is 12x. We subtract 1 from 3 is 2. The derivative of a constant goes to 0. So that's all. We just need to simplify now. So we have in the numerator 12x squared all over the square root of. So when you have a plus a minus b all square, so you're just going to say a squared, you square a, plus you square b, plus you say 2 times a and b. So a times negative b, so it's just equal to minus 2ab. Similarly, this is our a and this is our b. So 4x cubed all square, so it's 1 minus 16. 4 times 4 is 16. X cubed times x cubed. You add the power, so it's x to the 6th power. And then we also square this. 1 square is just 1. Now remember there is a negative outside, so this negative affects every term as they come out. So this will be negative. Now we say 2 times this times this, right? So it's like say 2 times 4x cubed times minus 1. So what we're going to get? We're going to get minus, but because of this minus that is outside, it's going to change to positive. So 2 times 4 is 8x to the third power. So we just simplify if we can. So this cancels this one. We have y prime to be 12x squared all over. Now this is, so what we can do is that because we just want something to come outside, we just want to simplify it further. We know that between this term and this term, we have 8x cubed that is common to the both of them. But bringing x cubed outside, this is not a cube root, this is a square root. So we can either say let's bring out x square, or we can say let's bring out x to the 4th power. So if we factor out x to the 4th power, now let's take out of them first. It goes into 16 2 times, so this is negative 2. And then 4 taken from in 6 is just x squared. So it goes into this 1 times, x to the 4th goes into x to the 3rd. You just left with 1 over x. So this is now 1 over x. So what do? We now say y prime to be, this is 12x squared. Now take the square root of this, the square root of 8 times the square root of x squared all squared. So the square root just cancel this 2. So you'll be left with x squared. Now the square root of 8 is like rewriting it as 2 times 4. So the square root of 4 is just 2. So it's 2 the root of 2. Then it's x squared. So outside we just have 2 the root of 2 x squared times the root of, we bring the positive first, 1 over x, and then minus 2x squared. So what can happen? This can cancel this one. 2 into 8 1 times, 2 into 12 6 times. So we're still simplifying. So y prime equals to 6 over, now the root of 2 times. Now we can say we multiply this one, so it's 1 minus 2x cubed all over x. So what we're going to do now, each expression, that is the expression within the numerator, we have their own square root. So it's the root of 2 times the root of 1 minus the root of 1 minus 2x cubed, and then divided by the root of x. So this root of x down here can go within the numerator. We can also rationalize this 2 so that we get rid of this square root of 2 in this denominator. So if this one goes up, we're going to have 6 square root of x times the square root of 2. Now the square root of 2 and the square root of 2 here gives us 2 times the root of 1 minus 2x cubed. So this 2 goes into itself 1 time, 2 goes into 6 3 times. We're still simplifying. So it's 3. Now the square root of a times the square root of b is just equal to the square root of ab. So because of these two having the same root, that is square root, so we can just say 2x all over the square root of 1 minus 2x cubed. So we can now call this our final answer for question number 6. So let's do the last question quickly. Now, in most cases, you will not have to simplify it to these levels. Sometimes your teacher may not even want you to reach this far. So you can just do what best suits you, So question number 7, we have y equals to sine inverse of ln of 4x all raised to the power 3. So we can now use the extended power rule, y prime. We bring this power down, 3. We rewrite this expression, sine inverse of ln of 4x all raised to the power 2. That is, we subtract 1 from the power down. What's next? We differentiate inside. So we know that the derivative of sine inverse of an angle is just 1 all over the square root of 1 minus that angle all square. So the angle here is ln of 4x all square times the derivative of the angle. So the derivative of this angle now, the derivative of ln of an angle is 1 over that angle times the derivative of the angle, which is 4. So this 4 cancel this 4. But just simplify further now. So what is it? We have 3 sine inverse of the ln of 4x all raised to the power 2. Now divided by, in the denominator right here, we have the square root of 1 minus ln of 4, ln square 4x. So you can say ln square 4x, or you say ln of 4x all square like this. It makes that's just the same. So that's it. That's it for this problem. Okay, there is an x right here, so the x is outside. So this is it for this problem, question number 7. So thanks ever so much for watching. Please don't forget to like, subscribe, and share our videos. And see you in our next class. Thank you.